Okay, so it's recorded now. Okay, so that's about the title. I mean the title for this subject, which is instrumentation for process control. In simplest word, it reflects a processing in the factory, in the factory or in the oil and gas industry. As I mentioned earlier, this one is meant for you to cater for the oil and gas company. Hopefully, all the electrical students got the opportunity to get involved, to be involved with the oil and gas industries. Yes, there are also power plant, transformers, etc. for electrical. But if you are the electrical student that having this subject in your transcript, that will be an added value for you. Okay, even though you are not specialized, this is just probably an overview or a general introduction for you about oil and gas industries. Okay, introduction. Okay, for this introduction, we're going to review what is the definition of process control, and then we're going to know the importance. I believe you should be able to extract from my explanation later on. And then after that, we're going to look at the basic element of process control. What are the component required for the process control, and then we're going to review one or two example of process control, or also known as open and closed loop control mechanism, because the process control is depend to the complexity of each applications. Okay. Okay, definition of process control. Okay, can you interpret and describe the difference or similarity of the following system? Have a look at this. Have a look at this illustration on the left and the right side. They are almost identical. I would say they are the same problem, which is a water level. We'll just take it as water level, or you want to make it as a oil in a vessel. That is also okay. A fluid in a vessel, and this one, we have a human try to open the valve here, the opening. Whereas here we have some sort of additional equipment to control. Okay, so you can actually see. Take 1 minute for you to digest these two. What are the differences and the similarity between these two? I will probably ask one or two for your opinion and feedback. Okay. Okay, Adila, what you can see the similarity between these two? Adila Zamri.
Di saya,
Adila, what you can see the difference between of these two?
the difference yang saya nampak, yang lagi satu tu dia menggunakan maksudnya tenaga manusia, and lagi satu guna sistem.
Alright, that is the difference. And how about the similarity?
To measure the measure liquid dia tu.
Mm-hmm.
Uh,
Dua nak measure
dia nak measure dia punya tu.
Alright. How about Iskandar Shah? Selain jawapan yang kawan awak bagi tadi. What are the difference and similarity? Kalau awak boleh fikir. If you can think, what are the difference? Are the difference?
Yang satu tu dikontrol oleh manusia, yang satu lagi tu automatic.
Okay, yang tu sama kan? Manual dan auto lah, tak apa. Tadi your friends told me that's controlled by human, this one machines. And then you rephrase it, you make it as manual, and this one is automatic. And then the similarity, you can rephrase what your friend just mentioned just now. One is to measure, and you can use other words apart from measurements.
Untuk detect dia punya level tu.
Detect level okay, or maybe I would say kalau kita if you want to rephrase it, probably okay, one is to measure the liquid flow, and some of your friends might say to maintain the water level at certain height, because there is lack of info here. It just what we call it, illustration, so you can interpret anything that you want. Okay, that can be both of the answer from your friends just now are valid and accurate. As you can see, this is actually a process. Okay, actually if you look at this word process control, actually process can be interpreted as one things, and control can be interpreted or can be described as another things. Okay, process is something that, as we know, a processing, process is to convert or to transfer from A to B. For example, after being analyzed or evaluate, after being undergone a certain processing or certain stage during the process applications. Okay, and control is the mechanism to control, and we know to control how to make it fast, how to make it slower, how to make it hotter, that kind of things. So yes, you are right. So basically, these are the process to control or to maintain the liquid, I would say oil in the vessel to a certain level, and then in which if it is we have a continuous incoming, if you can see Q in, a flow rate into the vessel, and we have a Q out. Q is a flow rate going out. So we want to maintain this oil in the vessel at a certain height, if you want, and then we try to maintain it on at a certain height. That's why the value of the output at this stage need to be balanced with the incoming, the input. So what we'll do here, we have a manual system. We have a manual system and a human being looking at the level here. So observe. So whenever this human look at this level, when it detect a rise, so what we do, he need to open the valve larger than, so that there will be no more fluid going out, so that this vessel will reduce, right? And if he start to see a reduction in this level, he need to close it a bit, so that the water level remain at this level. Okay, as you can see here, probably the threshold between the minimum and maximum is this point. So he need to maintain the water level between these 2 points, not to overflow and not to below the minimum level. So what he need to do at the end of the day, there is a continuous incoming and continuous for outgoing fluid. What he need to do at the end of the day, he need to control this valve, open and close accordingly, manually, to be there 24/7, just to control, to maintain the water level. While on the other part, if you can see, we have a system, the same system, but this one is controlled by a proper device, by additional device, with the actuator, controller, sensor, etc., so that This can be done automatically. Okay. Based on this one, okay, based on the one that you described, we discussed just now, we can maybe some of you maybe I need Hakim lah, Hakim Mak Said. Can you describe the advantage and disadvantage of these two options approach? The advantage and disadvantage of these two approach. One is auto, one is manual for this process control. Okay, boleh tak Hakim?
Boleh. Kalau advantage, kalau macam yang ada sensor ni dia lebih accurate lah berbanding dengan yang human punya.
Alright. Disadvantage?
Disadvantage mungkin dia punya cost untuk pembetulan.
Okay, complexity lah equipment dia additional. Okay, thank you Hakim. And Haris Akmal, advantage and disadvantage untuk manual punya operations.
Untuk manual punya operation Dr.
Saya.
Kalau dia punya advantage dia, everything can be controlled manually lah. Dia boleh ikut desire, ikut kehendak yang kawal tu, dia nak macam mana.
Itu advantage ke? Tak apalah, saya reward untuk ayat awak. Kita kata tak dependent dengan electric failure lah, senang
Betul.
Kalau elektrik tak ada, dia tetap boleh control, tak ada hal, betul?
Betul.
Betul aja. Lagi?
Kalau dia punya disadvantage dia, banyak guna tenaga lah.
Okay,
banyak
lagi?
Guna manpower untuk control.
Okay, lagi ada lagi tak? Banyak guna manpower. Awak larat nak duduk pacak situ 24/7.
Itu yang tak larat Dr. Sebab tu kita kena beli automatic.
Itu yang nama disadvantage tu kan?
Itu disadvantage.
Alright, good. I think overall quite understand lah. Process control, we want to control a certain process during regardless whether it is in the oil refinery, whether it is in the food and beverages industries, etc. But this one, this one, to be sincere with you, we are focusing more, if possible, try to address something related to oil and gas lah. Predominantly is about liquid, but not limited to the oil and gas. Of course, process control can happen everywhere. Everywhere. Okay, what is process? I just explained to you. This is just a word that you can read yourself. I don't need to read again. And what is process? Okay, what is process control? First, we have a process, broadly defined operation that use resources to transform input into output. As I said before, we want to make it from A to B. We want to make it A. For example, what is A? You need to define by yourself. What is B? You need to define. Say for example, what I try to explain here, transform A to B. We say we have a crude oil. We have a oil at a room temperature. All right, and then we want to transform this oil at room temperature into oil at the 100 degree temperature. Okay, that is to transform from A to B. You know what is the input, what is the output, so you know what to do. You know what to process in between so that your output will be 100 degrees Celsius of oil. So of course you will heat up the oil, you boil the oil until it will become 100 degree. Alright, so that is clear. What is process control? If we combine these two words, okay? If we combine these two words, it is the act of controlling. We want to control the final control element. If you can use the word here, okay, the word. Where's the pointer? Okay, final. Ya Allah. Okay, final control element ni, it is not it is a dedicated word. Final control elements, it is a dedicated word that been used in instrumentation and process control. Okay, Who can suggest what is the final control element untuk for these two case? What are the final control element? By the word, you should be able to identify what is the final control element. Hanafi, kalau kita tengok what is the final control element dalam case process control ni, if you can help me to identify. Sorry, Hanafi Adli, ada tak?
Ada doktor.
Ada Hanafi?
Ada.
Slow no suara Hanafi.
Slow doktor.
Agak-agak apa? What is the final control element? What is the final control component dalam case in this case?
Water level.
Water level, final control element. Okay. Okay lah. That is acceptable. Means that you tahu you nak control final parameter tu kan. That is acceptable. But to be precise, it is the equipment. It is equipment that will control the water level. Partly correct sebab you mention this is the water level is our objective. We want to maintain ataupun we want to regulate the water level at this certain level, and what we use to control this one is actually this one valve. This is the device that actually control the water level. I hope I think everyone can agree with me. Of course, if you open this one, the water level will decrease or increase depending on this one. So by looking at this example, I truly I do believe that all of you can actually appreciate what is the final control element to change the manipulate variable. Okay, Hanafi, yang you mention tadi, the water level tu is actually manipulated variable. Alright, what we have manipulated variable. Okay, Razin, saya nak cuba panggil sebanyak mungkin. Nanti mungkin next class tak apalah, kita buat bentuk-bentuk lain. You don't worry lah. Saya saja nak kenal dia. Razin?
Ya, saya.
Can you suggest other manipulated variables? Apa lagi selain water level? Dalam proses control.
Sensor for the water level.
Sensor variable ke?
Dia punya
Okay, you first need to understand what is variable. Variable means something that can be changeable. Okay, so it means that the thing that we want to varies.
The water level.
Okay, water level, that is right. Lagi apa lagi? Contoh kata water temperature. Like what else? The flow rate.
Volume of water.
These are the things that we want to control. Okay. To maintain the variable at the desired set point. This is another keyword there. Set point. So we set the parameter. We set the water. We predetermine the water level that we want to achieve. Then only we can change the manipulated variable. Without the set point, you cannot achieve the what is termed by process control. Alright, this you can always use this definition for the official one, but of course other definition that reflect to from your understanding that is acceptable, as long as you don't leave the keywords. For example, like final control element, manipulated variable, and the set point. Okay, so far clear at this stage? Saya very
Doktor.
just nak bring all of you into this course. I mean, to draw your attentions to some important components to get the feel for this course, because of this one is not my expertise. Instrumentations, mine is high voltage, but from my experience in the Petronas for about 1 year, with the Petronas for industrial attachment. So I can really appreciate this kind of process control. And not to worry that we're not going into details about the instrumentation like PLC, the design. This is just to give you a overview what is to be expected in the oil and gas industries. Okay, definition of process control. Process deal with regulations. Again, sama. How we regulate the process by using. Okay, how we going to achieve the regulation? How we going to achieve our objective to set the water level at the certain threshold, at a certain level? First is by using a sensor. Two is by using final control element. One of them is valve and control system. Nanti kita akan tengok each of these individual three components. Okay, sensors and transducers. These are two different things. Take a note that these are two different things. Sensor is the one that measure the difference. Say, for example, we have the water level. If we return to this point, if you look at this one, okay, considering this is a liquid, so sensor, the sensor that we use is a ball here, so that it can float in the liquid and it can change the sensor. All right. So sensor will send a signal to the valve. Okay, sensor, this signal will send the signal to the valve. Okay, will send the signal to the valve via or through this one, actuator. Okay. Actuator is the one because the sensor itself cannot. You understand the sensor is just actually in this case is mechanical, is a floating ball, and some of the sensor are maybe just measurement in terms of voltage and currents. How come the voltage and current can move the valve like a human? So it means that there is the need of actuator. Actuator is the one. Actuator is the one that receive a signal in terms of voltage and current or any kind of signal, and then it will move. It will transfer the the signal into mechanical operations. Means that if the actuator receive a signal of 1 voltage, they know. It knows that it need to make a turn into a 120 degree, for example, or it need to make opening of this one half centimeter. So it means that the actuator is the mediator between the sensor and the valve. Valve is the last. Or what we call it as a final control element, final control component. Without the valve, actuator cannot control the flow rate here. Without the sensor, the actuator will not able to decide whether it's need to open or not. Without sensor, without actuator, the valve cannot be open. So these are some important element of process control, right? Sensors and transducers. Okay, final control elements and a control system. So we have by looking at this one, so we have a sensor and actuator. Okay, this is the kind of sensors and actuator. That's why they come together. We have the final control element, and last but not least is a process control. Like control system, process. Control system. This is the system that we're going to control an oil in a vessel at a certain height. Okay. So these are three important elements or three important components in the process control. And in the next subchapter, we are going to look into details of the sensor, of the transducer, of the final control element, valve, and the control system. How to communicate? We are going to look these three item in great detail in the other subchapter. So means that at the end of the studies, at the end of this, at the end of the 13 weeks, we're going to learn only on these three elements. All right, only these three elements: sensor, transducer, final control elements, which is valve, control valve. We call it control valve, and the control system and communications. Control system, of course, it involves communications, some coding, some algorithm, or some communication between the PLC, programmable logic circuit, and to the actuator. Okay, process control application can cover anything that measure or control some variable. Okay, like what your friends mentioned just now, we have a process control applications. Okay, not limited to oil and gas, as I mentioned earlier. It can be a food processing. It can be related to conveyor belt. We can imagine an ice cream on the conveyor belt. After one stage, it'll come to the coating with the chocolate. After a later stage, it goes to the another stage, which is it drop peanuts and etc. That's example of ice cream. Of course, as an engineer, we are not looking for this kind of things. We particularly looking at the what we call it, industries that closely related to our degree level, which is electrical and electronic. Okay, what we can control, what process can we control is actually flow rate, and flow rate. Okay, and then we have a level, like your friends mentioned just now, water level. We want to make at certain height. Okay, we have, say for example, the variable is gas, so we want to control the pressure. What will happen if pressure exceed a certain limit? What will happen if the pressure is reduced below a minimum level? So we need to pump in, and we need to control the temperatures, density, liquid density, the alkaline, the pH level, conductivity, concentration, and etc. All right, so we have many control variables, many control variables. If you look carefully here, so this control level normally is related with liquid and gas, mostly liquid and gas, right? Okay, for example, we have this one. Okay, we have the oil and gas power plant. Okay, obvious this is if you pass through Parker Terengganu, you will see Petronas power plant, and you will see this kind of scenario in which a very high tower, vessel on top, and then we have so many gauge, here gauge, here gauge, everywhere is gauge, and safety railing, etc. These are the most common device in the oil and gas industries. Okay, if we translate this real image into a process control schematic diagram, it'll become like this one. Okay, for example, we have a pipe in and we have a pipe out. Okay, we have a vessel 100%, we have the set point, we have a graph for measurement and analysis later. We have a temperature level in which you want to measure the temperature in case it depends on the needs of each process control. It could be this one to monitor the temperature, and we don't care about the fluid the flow rate and etc. But it could be a flow rate and we don't care about the temperature. It depends what you want to control. Okay, so like this one, like previously I mentioned, we have say this is thermostat. Okay, we have a temperature. This measure the temperature, and the temperature is fit into the actuator. This is the actuator. It receive a signal and then it convert this this temperature will be converted into digital signal, and then this digital signal will will be read by the actuator to make the movement of incoming valve, final control element. Or there is also another valve here. For example, in this case, they don't control the output valve. If you look carefully here, they do control because they control at the incoming. So the application can be a difference. Okay, this is rather a complicated, several processes, in one diagram. We have the water level here, and maybe we have the temperature at this point, and maybe we have the mixing at this point. Okay, so the engineer is the one responsible to design the coding, like this one, PLC instrumentation, so that what will happen, you can view, you can actually monitor from a control room. Kalau dekat, if for the Petronas control room, it is about is as big as your, what you call it, lecture hall. Sometimes it's about the lecture hall in G3, very big with full of screen, and each engineer have their own responsibility. They may no need to monitor all the time because everything is equipped with alert and buzzer, etc. So they just to be there to stand by if anything happen beyond for any abnormal conditions. Okay, before we come to this one, importance of I would like to show you this video so that to enhance your understanding.
In an automatic control system,
I'm not sure whether you can hear. Okay.
Controller initiates a corrective action.
Can you hear very well? Can you hear correctly?
Yes, Doctor.
Yes, Doctor.
Yes, Doctor.
Good. By the way, I will upload all this material in the author. Later on, you can have a look. Okay, no problem.
Based on the difference between the signal controller causes of final control active actions that controllers can provide are called control modes. With two-position control, a signal from a controller causes a final control element to move from one extreme to another, such as from on to off, or from fully opened to fully closed. To see how two-position control works, let's look at an illustration of a sump pump arrangement. In this system, a pump draws water out of a pit or sump. A float with a rod is the sensing element in the system. The float rod has two collars, which serve as stops for a linkage that connects the rod to a switch. It's part of an electrical circuit that starts and stops the sump pump motor. If the level in the sump rises, the float also rises, and the lower collar on the float rod pushes up the linkage to turn the switch on. This starts the sump pump motor. As the pump draws water out, the level in the sump drops, and the float moves down. When the water reaches the minimum level, the upper collar pulls down on the switch linkage, shutting off the pump motor. Now, in a two-position control system, a certain amount of change can occur in the process without causing a control system response. This amount of change is called the dead zone. The dead zone in this system is controlled by the positions of the two float rod collars. The dead zone can be reduced by moving the two collars closer together. A smaller change in level will then turn the pump on or off. But even though the water will be maintained at a more constant level, the pump will turn on and off more frequently. And this overuse could damage the system's components. With proportional control, a controller's output signal is proportional to its input signal. In other words, if the input to a proportional controller changes by a given amount, the controller's output will also change by a given amount. To explain proportional control, we'll...
Okay, more or less about what I just explained to you, except he brought out another example. And Okay, and there are several more examples you can view yourself to enhance your understanding. But I think this is very simple and quite straightforward. No, not very complicated. Not with the mathematical operations. No, it's just understanding. Okay, understanding, and for you to understand, to appreciate what is the process control, what is the instrumentations, and process control particularly in the oil and gas. Okay, if you look carefully at the end of the video, not the end, at the end of this one just now, we did mention about, where is it? Okay.
With proportional control, we'll then turn the pump on or off. But even though the water will be maintained at a more constant level, the pump will turn on and off more frequently.
Okay, you did mention about the safety, about the safety of the control system itself. Okay, so why and he addressed of any kind of feedback or feed forward that we need to look into, so that we can avoid about the burning, the machine to work at the very maximum level. So the importance of process control, there are three ultimate objective of the process control. These are the keywords. We want to go for safety. If you review previously, if you recall back what your friend just mentioned to us before, you will see, oh, we don't want to work 24/7. It just waste of energy. It just if anything happen to the machine, the human is the one to first explode. For example, if you're talking about oil and gas, we want to go for safety, so we just want to put the equipments over there. Okay, we want to go for reliability. We want to as accurate as possible, so that the productivity can be improved, and what most important is economical and cost effective. We want to waste time, we want to waste energy, and etc. These are the three ultimate objective of process control, instrumentation and process control: safety, reliability, and cost effective. Okay. Okay. Okay, we want to go for product quality, consistent with the product quality. Why we want to, how we going to maintain? Of course, if we are using a manual approach by human being, there must be a very big gap or differences or discrepancy between one and another. But if you go for a device or measurement device, equipment, sensors, things like that, and then the variations in terms of the final product can be reduced or minimized. Lower manufacturing costs, detecting faulty elements throughout yield the product quality are maintained. So means that with the process control, the company or the manufacturing company able to detect a faulty, faulty items at the first place, so that they could rectify, so that the final output product remained with a high standard and high quality. Otherwise, if we just continue with the same defect product, and then we going to end up with a tones with the output with a defect product, and that will cause a big financial damage to the company. Okay, other than that, we are looking at the environmental performance, OSHA, environmental safety and health. Okay, system can give you early warning of rise and emissions. For example, we have hazardous gases, so that the system can detect, and then it can give a signal so that we can escape from the hazardous gas emissions, and we can improve. Okay, energy saving to reduce wastage, improve safety, as I mentioned. It could warn you for any abnormalities. So I don't need to to describe this. I do believe you all can appreciate this kind of things. And of course, not limited to these 3 and 6 point. You can always come up with your own justifications or your point with the proper descriptions. Because if we just put improve safety, okay, for example, the questions the test or questions ask about the importance of process control. Describe the importance of process control. You just mention improve safety. Yes, improve. How it can be improved? You need to address that. You need to justify. You need to clearly mention how it is will be improved. If the questions give 1 mark, then only you can mention it is improve safety. But if the questions ask about 2 mark, give award or award you 2 marks, you need to provide a explanation. If 3 marks, even more. Maybe explanation with example. Okay. All right. Basic element of process control. Okay. Basic element, as I explained before, there are 3 main categories. Sensor actuators. This is 1. Final control elements. This is 3. And last but not least is the process itself. The process. Or if we look at these illustrations. Okay, if you look at these illustrations, we can see, okay, we have a process in the middle, and we have the manipulated variables, which is the input, and we have the control variables, the output, and in some cases, in dynamic conditions, we always have a disturbance. Okay, disturbance is something that we don't want, but we cannot eliminate, we cannot decline, we cannot avoid in the system. For example, okay, for example, what are the example of disturbance? Siapa, anyone? One Sabrina, example of disturbance. What do you think, or what you could think? Something that we don't want that can affect our process. Tak terfikir. Agak-agak je, tak apa, it's okay. Okay, saya cerita sikit. Say for example, you want to heat up a oil and an oil in a vessel. Okay, and you are now in winter season. Okay, the winter, the temperature, the temperature in the winter will be a disturbance to your heating process. Means that the overall temperature of the oil will greatly affected by the winter season, which is very cold, and then we need to heat up the oil, and this will become disturbance to the system. And for example, if you are in the Middle East, in a very high temperature, and you need to cool down the to cool down the liquid, any liquid, and the high temperature will make you extra effort, quote unquote, extra effort to cool down the liquid. So that is something that we cannot avoid, we cannot eliminate during the process. That is what we call disturbance. But there is a way. There is a way for us to address or to tackle the problems. Okay, let's see later. Okay, basic element. Okay, we have okay, this is normal situations. Okay, what will happen if we have disturbance? Okay, even the complex process control, instrumentation process control, this disturbance, okay, manipulated variable plus this disturbance, and then it'll become the output variable. What happened is actually this disturbance is fit into a control system at this point, and it fit into the output, and then the manipulated variable will be assessed of the presence of this disturbance, and then they already can predict, then the process control can goes smoothly. Or the disturbance can be fit into the output. Alternatively, it can be fit into the output, and this output will send back signal to this one to make a correction, to achieve the any desired process. So this is what we call as this is what is required as a feedback. Okay, why we have disturbance and undesirable things? So we need a feedback to give a signal to input our output, or to make adjustment so that our process will reach the set point. Okay, we will get the set point. Try to use see if this one would. Okay. Okay, set point. For example, alright. So that is okay, that is the problem with the disturbance. Okay, let's move on. And then we have a process. Okay, see the disturbance in this case is taken into account as the input. We have the input, we have this disturbance, so that the disturbance in this case is become the input, because it is something that we need to take into considerations to be executed by the process, so that we achieve the measured output and unmeasured output. Later we look into this. Okay, and if we going to transfer into control representation, this is input output. This is input output. This is control representations. So we have a process. Okay, the process the output will be feedback to the controller. Control will send to the input manipulated variable, and then it will change accordingly. Or disturbance input can be fit into the controller directly, as I explained in before. Okay, this one. There can be 1 here and 2 here, option. Or it can be either 1 or either 2. Okay, I don't want to explain in great detail on this. We're going to look into it later when we come into the actuator, sensor, etc. Alright, in this case, if you want to look at a block diagram, okay, we have the process control here, 1. We have the control element, and we have the measurement. What happened is that, okay, we have a process, the process going downward, okay. We have a control element, for example, the fluid level, the fluid temperature, the flow rate, etc. Okay, fit to process, and then process, and then measurement. Measurement is now become a sensor. Measurement will be feedback to the input control, so that control can control the finite element, the finite element, so that it can be it is in the good loops, so that we achieve the desired final the set point. Okay, if we more example like this one, we have a controller here, the set point. Okay, we have a flow pipe here. Okay, a pipeline. We have a pipeline, and we put a gauge here. This is why you see a lot of gauge along the pipeline, and you have here along the pipeline. This is the gauge, the function of the gauge. It is actually to measure pressure and current. This is pressure to current converter. This is how we communicate the signal from mechanical into the signal, or signal into the mechanical. Pressure is mechanical, converted into current, and current is converted back into pressure. So in this case, we measure the pressure, and then it send a signal, and then we have the set point at the controller. Controller decide what to do, and then it will send an instruction to this pneumatic actuator to control the valve. Right. Okay, so it just the same. It just a repeat from what I just explained before, except this one got some details on it, and this one is the block diagram, also the same. I don't repeat. You can look yourself. Okay. For example, again, we have the water level, manipulated variable here. Control variable is the fluid, or the height of the water level. And then we have, what is this? LT. This is what we call as level transducer. It measure level controller or transducer. We have the set point here. We decide here. We decide at the control, it has to be 1 meter high. Right. So we have a valve here opening. You can decide this is the one. Okay. Error. The difference between the input and output, that is what we call as error. We have the set point output, we have the input measured. So the difference will become the error. This is the one that we want to minimize the error as minimum as possible, to reduce the. Okay, now very simple one, PID. Okay, what is PID? Process and instrumentation diagram, PID. Normally we just call it PID. We don't put N here. Okay, it's okay. You can call it PID, PNI diagram also okay. So what is PID? Okay, what is PID? Okay, the PID is actually process and instrumentation diagram, just like the symbol in your electric circuit. We use, if we are looking at the electric circuit, we have a circuit here, for example, battery, and then we have here ammeter. Okay, and then we can have voltmeter, and we have ammeter here, ammeter, and then you can measure anything. Okay, we know this one is voltmeter, and we know this one is ammeter. Similarly to the process contour and diagram, they also have their own symbol and diagram. For example, normally in PID diagram, they will just mention as alphabet. Alphabet LT, LC, LV. You will see more. Okay, what is LT? Level transmitter. What is LC? Level controller. What is L100? This is LV100. Level valve, control valve. We have a certain rating, etc. Okay, so they have their own illustration to really to display the control system as simple as possible. If you want to put the real image or the block diagram, that might be a complicated. You need to draw a sensor, a transducer, make like this one, and then sensor connected. This will become extra hassle to the diagram. Might as well they just use a for PID, they just use a symbol, LC, LV, LT. 100, what is 100? Is the level, the magnitude. For example, if we are looking at 100 degree, they will say 100 degrees Celsius. Okay. If these are more example. Okay. More example, TIC. See? TT, what is TT? What is TE? What is FT? What is FIC? This is if for instrumentation and process control engineer, they should well verse. They should alert all of this symbol. And if you can see this one, a rather bigger control system, you have many system in here, but what you see here, PC, IP, IT, LC, LT, PT, pressure, transducer. We have lots of symbol to represent our instrumentation and process control. Okay, now, what is the difference between instrumentation and what is the difference between instrumentation and process control? What is instrumentation? What is actually the instrumentations? Abdi Wali, again. I'm worried you. Abdi Wali, are you here? Abdi Wali.
Yes.
Yes, Abdi Wali. You are from Middle East, right?
Yeah, I'm from Africa.
Africa.
Yeah.
Okay. What is instrumentations? What is the what do you understand about instrumentations?
I think this is the equipment that will be instrumented. The some measurement like
what? That is almost correct.
Yeah.
Like example?
Means that maybe sometimes you drink the water 1.5 liter water maybe.
Okay. Good. Adi Shesha.
Yes, doctor.
What do you understand about instrumentation, or what you, if we say as the instrumentation, what comes to your mind? What do you understand? What you could imagine as instrumentations? Process control, now everyone dah dapat, I think everyone got can appreciate. At least we know the components, what to be do. How about the instrumentation? What are they?
Instrumentation is usually like how we apply the process, doctor. Like, how to say, like in a factory, they will have the process where the food will go through some sort of cooking and everything, packaging. Is that called how we instrument the process?
Okay, partly that is process control.
Okay.
Process control and instrumentation is bread and butter. They should come together. Okay, what is instrumentation? The instrumentation is actually the complementary of the process control that you just mentioned just now. That is right. But to be precise and to be exact with you, it is actually the measurement device like Abdi Wali mentioned to us before. It is a gauge. It is the gauge. For example, like this one. If you, I'm not sure whether I have an example here. Not, where is it? Oh, tak ada. It is actually the gauge. Okay. Simple one like this one. Okay. Mana dia? Alamak. Lah, saya just use this one lah. Okay. Simple like this one. Mana Wait. Dia ada dalam next slide tapi tak apalah, saya tunjuk quickly. Alamak. Okay. Kalau kita tengok at this. Okay. We are looking at this one. This is the instrumentation. I mean the gauge on the pipeline, the gauge, the measurement device that display the readings like a flow rate, temperature, etc. All the circle things here. This is what we call as the instrumentation, the device that we use to measure, the device that we attach to the pipeline, the device that we attach to the vessel, the device that we use to display the measurement. That is what we call instrumentation. That's why what Adi Shesha mentioned and Abdi Wali mentioned just now is particularly right. They are just complement to each other. Okay. So the gauge, see a speedometer, like this speedometer things, these are what we call as instrumentations. Because process control without instrumentation, I like this one here. Okay. Process control without instrumentation cannot be achieved. How we can achieve the process control and automation without the instrumentations? Means that we are going to measure without this device. How we going to know the reading, the result, the current pressure, the current meter, the current temperature? So without the instrumentation, definitely we can achieve the automations or process control. They are complementary or bread and butter. Okay. So it's good to know that you understand on the spirit or the principle of this control. Ultimately, what we're going to achieve is actually the automation. We want to avoid the manual, and then we want to go for the automation process. Okay, just to end up our lecture today for this session. Okay, we're going to see quickly on some control mechanism. Okay, the simplest that been used is actually on and off. What is on and off control? Very simple. You see the water level already up to the limit, maximum limit, you off. When you want to is down below the minimum level, you on, and then the water will start to fill in the tank. That is simple, on and off. Okay, what is rather complicated? You start to open loop. Open loop is and feed forward. We will look into this. Let me just show this one just with the example. It's easier. Okay, this is on and off control. Okay, so we set the temperature. This is the case of the temperature, and we have say this is boiler. We have the boiler on and off. Operation is just on and off, not to like lower the temperature and increase the temperature. No, we just use the simplest one: turn on and turn off. Okay, what will happen? Okay, when we turn on the boiler, okay, what happened? The temperature start to rise. Whenever it come to the set point, it detect as it reached the set point, and then it will immediately off, and then gradually there will be rise, and then at some point the temperature will start to decrease. When it decrease, touch again below the minimum, then the boiler will start to turn on again. At the end of the day, this will regulate at this setting point. What you can see here, the advantage and disadvantage of on and off control just by looking at this one, or just by your understanding. Anyone? Anyone can suggest advantage and disadvantage of this one? Simple one. Nabil Fikri.
Yes, Doctor.
What do you think about on and off control mechanism? You tengok dia naik, lepas tu turun, naik, turun, and benda ni akan continuously macam ni. What do you think?
Consistency.
Consistency. Lagi, apa advantage dia? Apa disadvantage? What you can suggest based on this one?
I do, Doctor.
Tak tahu.
Disadvantage.
Advantage, disadvantage, anything? Ataupun your comments? Kita tengoklah, dia on and off. Kita nampak benda tu adalah, first thing is simple. Simplicity. Maksudnya, senang je, on, off. Dia tak payah nak adjust. Naik sikit. Just a minor change. Increase a bit. Dia tak ada. Dia tak ada dah main benda tu. Dia on, off, on, off. Operation will be simplicity, easier. But on the downside about this system is actually a waste. If you can see, is overshoot and downshoot, overshoot, downshoot. So it's just a waste. So that this discrepancy should be lower. This error should be lower. If we have a mechanism that detect, when it reach this one, it start to turn off, or it start to turn off the say boiler, we want to control the flame, the fire that boil, make it smaller, bigger. That is rather complicated, but at the end, we will going to achieve a very good output. It depends to the requirement. If the system, we want to go for cheaper or less complicated, or maybe the output is less sensitive to this discrepancy, so that is fine if you want to go for this on and off control system. It's very simple and straightforward. This is open loop control. Okay, what is open loop? By looking at the title here, is open. Open means that we just control the set point at the first, and then we don't know what will happen. The process here will just operate as what we set here. Okay, means that it could be this one is subject. It's not specific. It's not limited to one fixed values. Means that it's open, like you did in the open-ended, what you call it, open-ended lab, right? Means that the solution for this one is not fixed to one. The output for this one is not fixed to one. For example, I'm telling you, say you set the set point here 100 degrees Celsius. Okay, and then it will it will run as 100 degree. What will happen if disturbance, like we have cool temperature out there? Okay, this one 100 degree, it will affect it to the process, and that is not taken into account to the input. Open, the output can be varies to a certain level. Okay, let's go for next one, feed forward control. What is feed forward control? What happened is that, okay, now we have the disturbance input, as I explained before. For open loop control, we don't consider the disturbance, but for feed forward control, we start to consider a feed forward. We start to consider a disturbance. Say the temperature, environment temperature will be fit into this one, and then it will make a adjustment, and then they know what is the set point. By the input from disturbance, they know this one need to be set as 110 degree. Okay, if the environment temperature is warm, this one we could actually set just 90 degree. That is the difference. We take into account the disturbance input to be at the control. So control action process, and this one can be achieved at the with a very good output, very high precision output, very with a very minimal discrepancy in the output. But on the other side, we have a very good output, the quality is improved, but on the other side, of course, the implementation of feed-forward control would require more additional device, more additional sensors, more complexity, and then hence that will increase cost. So that is the way as an instrumentation and process control engineer need to decide whether we need to compromise with the output or we need to compromise with economy. We've got a very limited budget. We have a constraint on the device and equipment, so we need to be balanced between them. Sometimes we try to moderate on this, we need to compromise on other things, right? Some we really need a high precision accuracy, so nothing much can be done. We need to invest more and more for this kind of things. Okay, and lastly, we have a closed loop. What we call it, just now we mentioned as open loop, and now we come to the closed loop. Closed loop is even better. Why is better? We take into account of the disturbance, and the other side, we also take the measurement of the output. Based on the output measurement, it's sent back to here, and we plug in the values for the control action, for the control here, so that the disturbance input as well as the output values will be fit into the controller, so that it can be adjust accordingly, so that it can reach a setting point at effectively. Okay, so we take in, this is rather complicated as compared to the previous three control system. Okay, and this is of course the best to achieve the automations, right? And example, closed loop control. Okay, we can see here. Okay, we have a burner, a process to burn or to heat up the steel here, for example. And then we have transmitter here. We know the gas emission transmitter, what is the temperature and the CO2. Okay, and then we control the valve here, so they know what to do based on the reading of the output. They know what values to be fit into this one, so they could adjust accordingly, so that the flame, the fire inside the chamber can be adjusted accordingly, so that it can be lower and increase depend on the temperature, depend on the output of this one. So that I think that's all the four process from on and off, as simple as possible. Open loop, so this one also simple because we just control at the beginning, we don't care what is the output, and then we try to see the feed forward, in which we try to consider the disturbance input, and lastly we take into considerations of both disturbance as well as the output. Okay, basic control strategies use industry control system. Okay, this is the same thing. Tank level problem. Okay, we have a process 1 and to process 2. We have a vessel here, a certain height. The F1 is flow 1 and F2 is flow 2. Of course, if flow 1 and flow 2 is the same, so the water level will be at the same level, right? No issues. But what happen if this one change, this one also need to be changed. Okay. Basic control strategy used in the control system. Okay, I try to wrap up this one. Okay, for example, okay, we have a valve here. All right, we have the okay, feedback control strategy. Okay. Oh, I know. Sorry, this one. Okay, I think this one in previous class I keep it or I leave it for a student for you to look and to try to understand. Okay, first we have this problem. Sorry, I forgot. Okay, we have a tank level problem. Very simple. And please propose this one, the tank level problem, as a on-off open loop control, feedback control, and closed loop. Okay, these are the example. Okay, feedback control strategies. Okay, what happened? Okay, so they mentioned, they clearly describe this control mechanism as feedback control strategy. Okay, this is the schematic diagram, block diagram. This is the PIC diagram. Sorry, this is the PIC diagram. PIC diagram, and this is the block diagram. Okay, how about this one? Feedback control strategy 2. Feedback control strategy 1. Okay, to achieve one objective that can be achieved in various ways, in some options. So as I mentioned, it depends to engineer how to design it, whether we want to use an expensive device or we can't afford to buy expensive device, yet we need to go a very simple one. So for the same objective, any process control can be achieved via through various ways. This is feedback control strategy 2. How they control it? This one feedback to the input, and the other one feedback to this one to the process 2. They just control process 2. And okay, this is the feed forward. Tadi feedback. Okay, this is feed forward control strategy. Okay, feedback and feed forward, there are various strategies that can be used for this simple problem. Okay, so as a homework for every one of you, I will leave this one for you. Try to digest and understand, and probably next week I will try to ask some selected student to explain to me, to everyone in the class, about this scenario. I'll pick randomly, maybe about this one. So you should be able to explain. You should be able to explain what is to explain to the class what is this scenario or what is this scenario. Try to explain and okay. Just leave it this one first. Nothing to worry about this one. I'll explain it later in the next class. But for now, as for exercise, only look and try to understand these control strategies. Okay, I don't need you to propose a new one. At least I just need you to understand how we going to achieve, how we going to maintain the water level at this height through various approach. Okay. Right. I think we come to the end of this session, the introduction. So as a recap, to where is the Google Meet? I don't know. Okay, as a recap to everyone, I hope we already discussed. Okay, we already discussed in this instrumentation and process control. Stop sharing, stop presenting. Okay. All right. I hope I made to you very clear about the general introduction about the process control and instrumentation and process control. At least we have looked into what we general description of the process control, the one that we want to achieve, the definition of process control and instrumentation, the importance why it needs to be implemented, and the control element, the control element in instrumentation and process control, in which sensors, transducer, final control element, which is valve, and then the control system. We need to have the system before we can control. Of course, we need to know the variable, parameters, output, and etc. All right. And we have several control strategy. How to achieve the control strategy? Okay. Either we want to use an on and off solutions, or we want to use a feed forward, feedback, or closed loop, open loop. We have several options. So these are the introduction of the process control, the overview. So you have look from the beginning until the end. And for the next class, we're going to look into detail what is sensor, what is transducer, what is valve, what is communication signal, what is. These are the next topic of the for upcoming chapters. Okay, I hope. Okay, any questions? Any questions you want to ask?
No, Doctor.
No. Hani Hamizan.
Ya, saya Doktor.
Faham tak? Wah,
Apa dia?
bergema dalam gua Faham tak? You clear?
Faham, clear Doktor.
Wah, clear Saya tak tahulah you all tengah cecah air teh dengan kopi ke apa kan. Mentang-mentang semua tutup. Saya tak tahulah bergolek tak katil ke apa. But that's fine. This one is recorded by the way. You can always, I will try to upload this one, make available for all students. But that is not an excuse for you to skip the class. And probably due to the technical problem, maybe next week it'll be like recorded. Maybe we'll continue synchronous like this one. It'll be alternately, maybe. Maybe it depend. All right. So okay, that's about it for this time. And in the next class, I will further explain, or maybe in the WhatsApp group, I will further explain about your assignment, group assignment, coursework, project, anything that is required for assessment. Okay, so very lucky. I don't think for this subject would require heavy mathematics. There will be no Laplace, there will be no integration, differentiations, all the charging that you don't like, and there will be no derivations. It just there are some simple mathematics, but that will test only on your understanding. Okay, so I hope everyone can score on this subject, because actually this one is the and it is been introduced to you as elective, anyway. So there are 4 other courses that you can choose from, but this is one elective, so it is not fundamental. Why EMT is fundamental? Why is the electric circuit fundamental? That is the core subject for electrical engineer. All right. I think that's all for today. Just anyone you have questions, just let me know in the groups, or remind me, PM me, no problem. You can ask me, and I can actually respond to the groups, and I will let you for any changes, for anything that it will be posted on the WhatsApp groups, and maybe the authors as well, right? So ada soalan? Tak ada? Sure Selamat menyambut Maulidur Rasul tomorrow for all Muslims. So banyak-banyaklah berselawat sempena birthday Nabi kita. Esok kan? Ke lusa?
Esok.
Betul
Esok Doktor.
Selamat bercuti, tak apa. And you gunalah ada masa yang ada nanti, try to have a look on what I left to you. Just try to understand. Next week I try to ask you randomly lah, macam ni, just pick name 1 or 2 names, lucky names, and then you should be able to explain very well. If you don't understand, you can actually ask me, or maybe discuss with your friends. But I think that one is simple and straightforward. It just need your quick revisions. Okay, and I think that's all. So I shall see you next week, inshallah, on the same time, and probably, let's just make it as official appointment at 3. Would it be okay? Because sometimes I've got meetings and then couldn't take lunch and need to solat and everything, so it will somehow delay. But are you okay to start at 3 p.m. or that's too late for you?
It's okay. Okay, doktor.
Okay je tak rush sangat nak solat nak apa.
Betul, doktor.
Okay, tak apa. Kalau if we have any other changes, I will let you know. Okay, it's okay pun. I'll keep you posted. In case pukul 3 ke 2:30 ke, just standby lah lebih kurang. Atau saya akan buat announcement lain lah. I also aware that last minute is not good, but I try to avoid it. Mungkin kalau saya kata, next week nak start, saya cuba beritahu awal 3. So that you dah buat apa-apa, you tak perlu rush. Pukul 2 ke datang beria pukul 2, and then kelas pukul 3, kesian awak kan. Saya cuba take a note on that. I'll try to be fair to you and to myself as well. Okay, with that, thank you and have a good day. Salam alaikum to everyone Muslim, and I'll see you next week, inshallah. Alright, Assalamualaikum warahmatullahi wabarakatuh.
Thank you, doktor.
Alright,
Thank you, doktor.
thank you.
Thank you, Doctor.
Sure, thank you and all the best.